Hello and welcome to another video. This time, I will create an example to use the timer known as the Watchdog. It is essential to use this protection method in a microcontroller, especially if the program counter gets stuck in an infinite loop. This is not so much due to per-user programming but rather due to radio interference known as EMI or power fluctuations. From now on, I will use this protection for any project with the ATF32 microcontroller. In the image, the path where examples with this timer can be found is shown. Please refer to the previous video titled Asynchronous Delay with the ATF32 Microcontroller from Artery Technology, where I indicate where to download these examples. In the Workbench tool, it's basically the same as the previous projects. One input on the microcontroller is for the push button on the board, one output is for activating an LED, along with the programming terminals, and the ones where the oscillator crystal is connected. What I've enabled this time is the Watchdog option, which can operate in window mode. In this option, if the timer is updated too early, it causes a CPU reset. In my case, I don't want the timer to function that way. For the prescaler, I chose the maximum value, which is 32,768. The down counter value is 7F in hexadecimal, and it can't be set to another value. To avoid operating in window mode, that related value must be equal to the down counter, because if I set a value, say the minimum which is 40 in hexadecimal, the window would be about 17 milliseconds. With the parameters I want, the Watchdog will overflow in approximately 17.5 milliseconds. I would prefer a higher value, but this is the maximum possible with this microcontroller. Here I have the code generated by the Workbench. There's a new function that initializes the Watchdog. It resets its default values, then sets up the period, window values, and the counter. Here it is indicated, as a commented example, that if you want to enable this timer, you need to execute this function, wdt_enable. The first thing I do is turn off the LED diode by setting the pin that controls it to a logic high. Then I enable the Watchdog timer. Following the examples provided by Artery, in the main loop, by setting a value, which is the maximum, to the Watchdog, I prevent it from reaching 0 since it is a countdown timer. Also, within the main loop, an if statement waits until the user presses the button. If this happens, I set the line controlling the LED to logic 0 to activate it, and then the CPU enters an infinite loop to trigger a reset by the Watchdog. Here, I have the development board with the previous example, where two LEDs turn on and off periodically. Now I go to the project, right-click on it, and select the option called Debug as, then choose Debug Configurations. I wait for a moment, and in the window that opens, under the @link option, I click the button labeled Debug. The software recompiles the project, and no errors appear. Then, it tries to connect to the board's programmer debugger. When it finally does, the debugging halts at the first line of code in the main function. I click the button to continue running the code, take the board in my hand, and press the user button. You can see that the green LED turns on, but almost immediately turns off due to the reset caused by the Watchdog. The AT32 ID software also indicates in the debug console that a reset has been detected. I do it once again, and the same thing happens as previously explained. That's all, thanks for watching the video.